we're going to start sketching these quadratics. We're going to do the graphs of them. And without getting too into details as to why this formula works, we're going to use, they call this a turning point formula. Sometimes I prefer the phrase the vertex form, because that's what a turning point is a vertex. But that's using a more fancy. But what they mean by turning point is either a curve that opens downward like this, that would be the top point, or a curve that opens up would be the bottom point. So that's where it turns, goes from down to up, or goes from up to down. So in this problem, they give you the formula, and instead of saying x equals negative b over 2a, they write it as an ordered pair, which I like, but I think it could confuse people. So in exercise 1, we have this equation, and what they do is they ask you to, first of all, find the y-intercept. So as a reminder, it may have been a while since the last time you've heard me say the y-intercept is when x equals 0. So that's kind of nice, because if you plug in 0 in for all these x's, 0 squared is 0, 4 times 0 is 0, and if you do 0 plus 0 minus 45, it's pretty clear to me that negative 45 is the y-intercept. What you should notice from this, and a pretty big deal, so I'm going to put it in a darker color or brighter color, is the c value in this form. You see how it's ax squared, so a would equal 1 in this problem. B is equal to 4 in this problem. And then the c value is equal to negative 45. That if it's set up this way, the c value is your shortcut for the y-intercept. So as I move on to the next one, similar in the sense that it's the x-intercepts, so it's when y equals 0. And this is what we did in the previous section, where we set the quadratic equal to 0, but this time I would find factors of negative 45, that would be 9 and 5, that add to be 4. And I agree that 9 plus negative 5 gives me 4, so in factored form we would write x plus 9, x minus 5, but remember what that means is that the x-intercepts are the opposite values. It would be negative 9 and positive 5. So there's not a shortcut. You actually have to know how to factor to get that answer. So if I do the next one, maybe I'll go back to this pink color, because the turning point, what you have to do first is that equation I talked about, negative b over 2a. Well, in this problem, the b value I told you was 4. I wrote it right there. So it's negative of 4 over 2 times the a value, which I mentioned was 1 earlier. Well, 2 times 1 is 2. You have to multiply before you divide in this problem. And negative 4 divided by 2 is negative 2. Now, before moving on to the y value, I just want to point out that this value, this x value, has to be halfway between these two x-intercepts. And I think that will make sense when I get to sketching the graph in a second. But you're not quite done, because you also need to find the y value for the turning point. Remember, a point has an x and a y value. I call it the vertex, though. And what you have to do is figure out what the y value is. Well, how do we find the y value? Well, if x equals negative 2, I need to go back and plug in negative 2 in for this x. So negative 2 when you square it is positive 4. 4 times negative 2 is negative 8 minus 45. So we get a y value of negative 49. So I'm going to draw a very, very rough sketch. I'm not going to spend a lot of time, drawing it perfectly. How about this? I'll move it a little bit over to the right. Something like this. And it's going to go down to negative 49 for my vertex. It has an y-intercept of 0, -45. And what happens is it's going to cross the x-axis at 1, 2, 3, 4, 5. So right here, and then as well as 1, 2, 3, 4, 5, 6, 7, 8, 9. So my curve is going to go all the way down here. This is not a very good, because it's supposed to be a U shape. There's a U shape to a parabola, to a quadratic. So here's the thing, is not every problem is going to give you all of that information. They're just going to ask you to do all of that. So determine intercepts, determine the turning point, and create a sketch of that. So if you list them all out, I think it makes perfect sense. Now here's your shortcut. The y-intercept, when it's written in this form, ax squared plus bx plus c, is always the c value. So without doing any math, I already know that the y-intercept is going to be way up here at 40. Now the x-intercept, there's a lot of work to do. I meant to put a dash there, and there we go. And excuse me, the reason why there's a lot of work is you have to set it equal to 0. And what I would do is start by factoring out a -2. So it would be x squared minus 8x minus 20. And then I could find factors of -20 that add to be 8. And that would be 10 and 2. And I would make the 10 negative and the 2 positive. So if I do this work correctly, it would be x minus 10, x plus 2. And my x-intercepts, I'll squeeze it right here, would be the opposite numbers, the 10 and the -2. So let's talk about the vertex now. The turning point is the word that they use here. You're going to hear me say the vertex, and I'm just going to underline it, is you want to use the equation -b over 2a. So as a reminder, the c value is 40. We don't want that. We want the b value, which is 16, over 2 times the a value of -2. So 2 times -2 is -4, and -16 divided by -4 is 4. And what should you notice about that 4 is it's halfway between the two x-intercepts. So if I were drawing this graph really well, I would be to the left 2 on my x-intercepts, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are my x-intercepts. I'm actually going to draw a vertical line at x equals 4. And I hope you would agree then that it's spaced out by 6 on either side of that. And I can figure out the vertex by plugging in 4 into the equation. Well, 4 squared is 16 times -2 is -32. And then 16 times 4 is 64. So that's 32 so far, plus 40 goes up to 72. So my vertex is way up here at 4, 72. And here's one more thing, is all of our, remember I called this 0, 40, where it crosses the y-axis, is all of my quadratics cross this axis of symmetry. Oops, I forgot to write 72 down. There we go. This is called the axis of symmetry, this x equals 4. And the reason why we call it that is every point is symmetrical on the other side. That's why this distance of 6 has to also have a distance of 6 on the other side. But I might be getting a little bit ahead of myself on this explanation. But the reason why I say that is if 0, 40 is 4 units away on this side, then it's got to hit again 4 units away on the other side. But like I said, I might be getting a little ahead of myself. So I'm just going to connect those dots. And that's what I'm more concerned about. Intercepts, turning point, and the sketch of the graph. We can also use problems like this for word problems. And, so we have a bunch of words that explain where this equation comes from. But all I really care about is this equation. The height is represented by time. And if you wanted to rewrite because at the very beginning of these notes we had ax squared plus bx plus c, you might rewrite it as h equals negative 16 t squared plus 88t plus 0, because we could add 0 at the end of this. And the reason why I'm doing that is so that you can identify that a would equal negative 16 in my problem, b would equal 88 in my problem, and my c value is 0. And why do I care about that to figure out certain things? Well, the c value is my y-intercept. So I know it's got to start at the origin. And then I can use my equation for the turning point, the negative b over 2a. Now I can do a little bit of this in my head, but I think I would probably struggle at figuring out what negative 88 divided by negative 32 is. So I'm going to use a calculator. So about 2.75. So if you were putting on your calculator, 2.75 is about right here, and that's going to be my vertex. And the reason why that's going to be my maximum is this graph is going to appear like it goes up that high and then come back to the ground. So that x value is the vertex, and that's the time it takes to get there. Maybe what I should have done is, instead of writing x equals, because the independent variable is t, should have wrote down that t equals. So it takes 2.75 seconds to get to the maximum height. But we actually don't care about the time. Well, actually we do. The time it reaches that height, so we just found that out. So that's the time. But now what I need to do is figure out the height, and we can figure out the height by plugging in 2.75 in for that problem. So if I did that, I'll just type it in, negative 16 times 2.75 squared. I already forgot what it was, plus 88 times 2.75. So we got 121 feet. Okay, I'm pretty sure it was in feet. There it is. So that's the maximum height. Now I'm going to kind of cheat to talk about when it reaches back to the ground. And it's based off of what I already said. Hopefully this makes sense, otherwise you can ask questions in class. So it takes 2.75 seconds to get up that high. Well, how much time would it take to get back to Earth? 2.75 this way would also need to be another 2.75. So what I could have done is just add those two together, or double 2.75. So it would take 5.5 seconds. So 5.5 seconds to get back to the ground. The other way to do this would be to set the equation equal to 0, and then you could factor and solve. Okay, so if you wanted to, you could set that equation equal to 0, factor, and solve. And we have one more problem that gives you the equation of this suspension bridge, suspension cable on a bridge. And we could answer some of these questions. We can answer a lot of these just based off of what we're doing. So assuming the turning point is at the midpoint of this, well, how wide is the bridge? What you would have to do is figure out the x equals negative b, so negative of the negative 0.457, so make that positive, over 2 times 0.0001. Now that would only find you this distance. So as you use a calculator, 0.4571 divided by, now I'm going to put it in parentheses of doubling that number, 0.00. Pretty sure I have the right number of zeros. Yep, so it's 2285.5